Hi everyone and welcome. Previously we have covered the introduction part of these two Modbus IO modules, and this Modbus IO module is brought to you by the Augmatic Technologies Private Limited, and they are the manufacturer of this Modbus IO cards. Okay, now this Modbus IO module is capable with the 4 analog input channel, 4 digital input channel and 4 digital output channel. Okay, and this Modbus IO card is capable with the 4 analog output channel, as you can see here. Okay, now in this video we will see these two Modbus IO modules in the action. We want to turn this LED on and off with this module. We want to sense the sensor data using this module. We want to display some voltage here with this module. Okay, and we want to supply the analog voltage to this module from this module. Okay, so this module is capable to provide analog output to the external world, and this module is capable to read analog data from external world. Okay, so I have connected these two cables here, as you can see here, these two cables to provide the analog voltage from this module to this module. Okay, and we will read those detail in the signals here. As you can see, analog input trends. Okay, so I have connected AO2. Okay, you can see here AO2 with the AI1. Okay, so AO2 is directly connected with the AI1. Okay, this sensor is directly connected with the digital input 1, or we can say DI1. This two LED light is directly connected with the DO1 and DO2, so I can turn on and off this LED using digital output 1 or digital output 2. Okay, I can sense the sensor signal from the DI1. I can turn this DC voltmeter on and off and display some voltage here using this analog output 1 channel. Okay, so let's see all those things in the action. Okay, now I have connected these two cables. Okay, this is the serial cables. Okay, I have looped it here, and then I am using the ATC converter here. Okay, let me show you that. As you can see here, this is the ATC converter, and here is the connector. Okay, so I have connected this way. Okay, and I have connected with this my laptop, so I can operate these two modules, okay, from my laptop using the Node-RED. Okay, so I have connected this ATC converter to my laptop. Now if I want to turn any LED on or off, then I can do it from my Node-RED dashboard. Okay, you can see I have turned on the green LED, and you can see here green LED is on. Okay, now if I want to turn off, then I have to again turn it back to off from here. Now if I want to turn on the red LED, then I can turn it on from here. As you can see, my red LED is on, and if I want to turn it off, then I can turn it off from here. Okay, now what I want to do is I want to sense the sensor data. Okay, so I can place this inductive thing here. Okay, and you can see LED is on, and here also on the screen you can see sensor is activated. Okay, so if I remove this screwdriver from here, you can see sensor is off. If I place it here again, you can see sensor is on. Okay, so this is how you can use a digital input channel of this module, and this is how you can turn on your or off your field device using these digital output channels. Okay, now let's see the analog output channel in the action. Now, as I already told you, the AO2 here is connected with the AI1. So if I change the value of AO2, then the value of AI1 should change. Okay, so if I change to 0.5 volt, you will see some change in the graph. Okay, so this is the raw value, I didn't mapped it. Okay, you can see the graph is increasing, and here also you can see I am supplying 0.5 voltage. Okay, you can see the graph here, it's a 0.49, so around 0.5 voltage I have supplied, and here I am getting the value of 22. Okay, now if I increase more here, then the graph should go beyond 22. Okay, you can see here, and here also graph is increasing. If I increase it more up to 1.5, then you will see some changes in the graph. Okay, so you can see here the value is 70. Okay, and here also it is stable. Now if I increase up to 4 voltages here, okay, so the graph should increase from here, and you can see the value got also increased in the AI1. So this AO2 is directly connected with the AI1. So whenever I change the analog output of this module, that also affect the analog input channel here. Okay, so this is how you can use analog output and analog input from this two module. Now if I want to turn on this DC voltmeter, then how can I do it? So if I increase my voltage like 0.5 voltage, I have increased from 0, but this didn't get on because this module is require some some threshold voltage to turn itself on. Okay, so I have to provide at least 4 volt to turn the display on of this device. So let me provide the 4 volt here. Okay, so once I provide the 4 volt, you can see there is some blue line, some blue LEDs. Okay, blue LEDs on 7 segment display. So it got the minimum voltage to operate. Okay, now if I increase the more, you can see it is increasing. Okay, it is going dark. Okay, it's a 3.24. Now if I go up to 8 volt, okay, I have provided the full voltage here. You can see it's 4.70 voltage stable now. Okay, so this module is providing analog output. Okay, and this DC voltmeter is reading the voltage, and it is displaying the current voltage here, but it is also consuming some voltage, so that is why it is showing the low voltage compared to the actual. Okay, so I hope this is clear that how to integrate this to Modbus IO with the Node-RED. Okay, I have created a flow. Okay, this is my flow for this. I will provide this flow in the description of this video. You can use this flow and you can integrate these two modules directly with the Node-RED. Okay, I have disabled the analog output 3 graph and analog input 3 and 4 graph because I am not using it right now. Okay, so that is why I have disabled it, and rest of the thing is working as expected. So if I want to turn off my red LED, my red LED is off. If I want to turn off my green LED, my green LED is off. Okay, if I take it, then my sensor is not sensing anything, so it is off now. Now if I want to turn off my DC voltmeter, then I can make it 0. Okay, it is 4, so it is still on. Now if I go below 4 voltage, then it is turned off. Okay, now I can go up to 0. Now if I turn off this analog output 2, then the graph will collapse here. Okay, so if I go to 0 here, then this graph will collapse. Okay, you can see here directly from 4 voltage it is going to 0 volt. You can see here it is previously 4 DC voltage, now it is going to 0 directly. Okay, so this is how you can integrate this to Modbus IO module with Node-RED. Now you can write the logic part in the Node-RED that whenever my sensor value gets high, I want to turn on the green LED, and whenever my sensor value is low, I want to turn on the red LED. So you can create a logic in the Node-RED, that is possible. Okay, and you can operate your industrial equipment using these two Modbus IO cards. Okay, so I hope this is clear to you, and this two card is brought to you by the Augmatic Technologies Private Limited. They are the manufacturer of this card. Okay, so if you want this card in the bulk or in the single unit, then you can visit their website. You can call them on their salesperson number and you can order as much as you want it. Okay, so this is how you can integrate this two Modbus IO card with the Node-RED. And in the next video, okay, we will see same thing, but we will see how to integrate this two card with ignition SCADA. Okay, so from ignition SCADA, if I want to turn on and off my LED, then how do I do that? If I want to sense the signal of my sensor, then how to do that in the ignition SCADA? Okay, how to configure your Modbus communication in ignition SCADA. So everything we will see in the next video. Okay, so if you have any concern or any question regarding this, then you can ping me on WhatsApp, Telegram, Instagram, anywhere, and I'll try to resolve your doubt as soon as possible. Okay, so we will meet you in the next video. Till then, take care. Goodbye and thank you.